So in this section we discussed a lot about ISV theories, intraseasonal variability theories, intraseasonal oscillation theories, and I mentioned several times this curious arrangement within the year where you have MJOs from about October to April and MISOs from about May to September. It's not a very strict division, and we also talked a little bit about the debate about whether MISOs are boreal intraseasonal oscillations that are actually the same as MJOs getting steered northward, or are they originating in the West Pacific where there is always instabilities being created by the convection weakening around the dateline because there is a front and so on. So that debate will go on, but why is there a transition at all, and what are the typical things that happen? So I'm just going to show a few figures from various chapters of a book by Bin Wang on Asian summers. He edited it, but let's start with this one. We are looking at the DJFM intraannual rainfall standard deviation. Obviously the northeast monsoon exists here, but you have the ITCZ mainly to the south with the SPCZ being prominent, so you see high variance or standard deviation over here. That's what I'll focus on. And when we come to JJS, obviously we have this split structure with the high standard deviation over the Indian subcontinent, but the marine ITCZ doesn't go away. The cold SSTs tend to break the ITCZ here, and you have the ITCZ moving to the north with the East Asian Asian monsoon as well, and SPCZ almost becoming quite weak, and so on. If you look at the this is interannual rainfall standard deviation. Sorry, I should have said that. This is the same thing, but for intraseasonal standard deviation of rainfall, and you can see that the patterns are essentially the same. Maybe the angle is a bit higher here, and there is more activity here, MJOs detouring and affecting the SPCZ, the South Pacific Convergence Zone, and so on. And there is a remarkable similarity between the two. And it's been argued for the monsoon season, which has also got similar patterns in the interannual standard deviation and the intraseasonal standard deviation, that there is a common mode of spatial variability that is controlling both time scales. Another way of saying it is that the interannual variability tends to project onto intraseasonal timescale, or that intraseasonal timescale is some sort of a intrinsic timescale for the monsoon, but same thing could be said about MJOs as well. And if you look at the ratios, you can see that the ratios are can be as high as order 1 or greater. You can see that here. So that tells you, so there is a transition from this season to this season, and there are similarities at intraseasonal and interannual timescales. If you look specifically at MISOs, we have looked at the MJOs a lot already in terms of their eastward propagation, the detours, the weakening across the maritime continent, and so on. This is from Bin Wang's book again, looking at composites of multiple years of MISOs. So it's looking at all MISOs, which included 58 in number, or the eastward propagating MISOs and the in situ MISOs. So if you look at all the MISOs averaged over the 75 to 80 degree east longitude band, you see the origin at around the marine ITCZ in the tropical region, and this clear northward propagation. So lag 0 is when you have maximum rainfall over this longitude band here. So you have you see this phasing here. Okay. If you look at the same all MISOs at averaged over 0 to 5 degree north, you can see that the origin at lag 0 on the equator, and a bit of eastward propagation but rapid weakening. So there is a kind of a limited zonal scale, but we've already talked about how the scales are different for the 30 to 60 day variability and 10 to 20 day variability. If you look at eastward propagating mesos, they look almost the same. But this 0 to 5 degree north is quite different. It has a much stronger eastward propagating signal. So the origin is around 75 east central western Indian Ocean. Then the question is, if they are propagating northward, are they convective activities always originating in the western Indian Ocean and being steered northward or not? And then you have to say how during interannual variability this part is different than the other parts, like in situ mesos, which are similar to here, what we called the 10 to 20 day. So they also have a northward propagation, but not as far north as here. Maybe there is a slight difference, right? So there are these multiple characters to mesos, and there's a debate going on about whether these are convections originating in the western Indian Ocean propagating eastward like MJOs but getting steered northward, or whether there are Rossby waves generated in the western Pacific, as Bin Wang and his group has argued, and they are being shifted northward by the background mean state of the monsoon circulation and so on. So there are two different questions. What is the origin of mesos? Are they the same as MJOs or different? And what is the seasonal transition explained by? Obviously, we can think of ITCZ as the prime candidate. You remember the animation of the ITCZ we saw, and I argued that in the eastern Indian Ocean there is a lot of activity with the marine ITCZ remaining there and the tropical convergence zone getting set over India during the monsoon, and the western Indian Ocean being cold and not having much of a activity in terms of the ITCZ when we look at rainfall pentads, right? This is a figure from Dwayne Walliser's chapter from the Bin Wang's group book on Asian monsoons, and it is showing May to June season and the July, August, September season. And again, it's kind of a composite, and you can see that obviously in the May to June season you have the Rossby wave structure, so convection happening here, either propagating directly north eastward or propagating eastward, strong Kelvin wave like signature crossing over to the western Pacific, and then there are some northwestward propagating features here. We will ignore the southern hemisphere, but obviously equatorial waves can have symmetric components with background circulation being different, so you have different amplification, let's say, to the north here. But in the July to August season, you have convection activity shifted, as we saw before, and there is still this northeastward propagation and eastward propagation, but this strong eastward propagation here is missing. So you have instead northwestward and southwestward propagation, and there is a separate convective activity here which is triggering off the propagation towards the northwest, 6, 7, 8 going into the Mayu Bayu front, East Asian monsoon and so on, and into the SPCZ here. So this shows a little bit better how the transition between the MJO season and the MISO season is happening in terms of convection and their propagation eastward or northward, northeastward and northwestward and so on. Okay, so I'm not answering any questions, I'm just raising these issues, saying that a lot of effort is put into MISO theories, MJO theories, general interseasonal variability, where it comes from and so on, but this transition is in my mind most likely related to the ITCZ transitioning with the sun and getting split over the Indian Ocean. This is the cloud fraction from Dwayne Walliser's chapter, looking at averages over 80 to 90 east, which is over the Bay of Bengal, and this is 125 to 135 east, which is essentially in the maritime continent, and this is looking at the entire year going from January to December as a composite. So you can see that there are active periods, break periods kind of things we talked about. So, or better to say convective phase and the dry phase. So increasing cloud fraction and negative cloud fraction. This is a filtered interseasonal timescale variability. So you can see that early part of the year and latter part of the year, either there is not much propagation here, and the northward, so this is, you have to be careful, longitudinally averaged latitudinal plot. So northward propagation happens starting in March, April, which is when the sun is moving across and ITCZ is being dragged across the equator, but over the Indian Ocean. The ocean holds on to the marine ITCZ, and the northward propagation is much stronger in this season at both these longitude bands, okay, whereas both longitude bands have weaker northward propagation in the beginning of the year and at the latter part of the year, which means during the MJO season, even though the ending of the season here is different because of the maritime continent monsoon versus the Indian monsoon and so on. So there is some northwestward propagation here that's visible in the composites, but not so strong here. So again, the seasonal divide between northward propagation or MISOs and MJOs is clear. One can also think of it in terms of how the eastward propagation and northward propagation and the monsoon drought and so on may be affected by these intraseasonal timescales. So if you look at the composite interactions between the Asian monsoon and El Nino Southern Oscillation, you can see the composite El Nino or minus La Nina showing the June, July, August of year 0 when the El Nino, so El Nino peaks in December, January, February. So you're looking at JJA of December year, SON of the same year, DJF crossing into the next year, MAM of the following year, and JJ of the following year. And the main point I want to say is that is to raise a question about whether El Nino is able to change the dynamics of JJA in terms of northward propagation versus eastward propagation, which can it likely explain the anomalies on the Indian monsoon. For example, we also have westerly wind bursts during most of the El Ninos, and some of them get very strong during some of the stronger El Ninos. So what is the relation between El Nino impact and the Walker cell shift and the seasonal split between the eastward propagating systems and northward propagating systems, and how is that related to monsoon anomalies during El Nino and La Nina years? So these precipitation anomalies give you some sense that maybe the northward versus eastward seasonal transition during June, July, August, or May to June is affected by the El Nino, which all westerly wind bursts are not considered MJOs. They are considered to be winter surges from either hemisphere, and there are other explains of cyclogenesis and so on and so forth. But nonetheless, many westerly wind bursts do have some relation with the MJOs. So that's an additional thing to consider in terms of the seasonal transition during normal years and how the seasonal transition between MJOs and MISOs to MJOs are affected by El Nino and maybe IOD as well, and the Atlantic Nino and so on. Anything that affects the monsoon, does it work through the intraseasonal time scale and the northward versus eastward propagating systems and their dynamics? Okay, so I just wanted to raise it not as a theory but as something that's not very well resolved and is not actually looked at in terms of theories either, theoretical understanding either. Okay, so just wanted to add that one podcast. Okay.